Great. Hello, everyone. I'm Katie Wetstone, and as George mentioned, today I'll be telling you about my project using machine learning to better target support for HIV-positive sex workers in South Africa. So first, I'd like you to imagine that you are a manager of an HIV-focused community health clinic in South Africa. So you are supporting a population of 2,700 sex workers. And keep in mind that in South Africa, roughly 58% of sex workers are people living with HIV. So you want to make sure that every single one of these 2,700 sex workers, one, knows their HIV status, and two, if they are HIV positive, you want to make sure that they are continually taking antiretroviral therapy or ART treatment. And ART treatment is incredibly important because it drastically improves quality of life for people living with HIV and reduces the risk that they will transmit HIV to others in their community. So to accomplish this, you have 27 outreach staff. So these people are responsible for everything from recruiting sex workers to get tested for HIV, all the way to facilitating peer support groups. And you have one mobile delivery clinic that can actually take ART medication directly to people. Some of the biggest challenges you face are that this is a resource-constrained population. So picking up ART medication regularly imposes direct costs, like the cost of transportation, and indirect costs, like the cost of time waiting in long lines to pick up medication that could otherwise be used to earn income. And the second big challenge is that sex workers face extreme discrimination and marginalization within their own communities. So a lot of these people don't trust their healthcare system and don't want to engage with that healthcare system in the first place, making it really hard for them to get the care that they need. So how do you decide how to allocate the few resources that you have to reach this large population? So this is the story of an actual clinic that I spoke with during my project. And the goal of my project is to help clinics like these more effectively target outreach, ultimately increasing retention on ART treatment, improving quality of life for HIV-positive sex workers, and reducing transmission in the population as a whole. So this clinic and a network of clinics like it have an existing partnership with Zenesis, a technology company based in San Francisco. Zenesis offers a data platform where these clinics can store data, collect data, track performance metrics. So for my project, I worked with Zenesis using this data that was already collected and already being stored to fit a logistic regression model. And what a logistic regression basically does is it takes a bunch of input variables, so everything from age, gender, what someone has been tested for, how many times they've been to a clinic, and it outputs a probability. So in this case, for each individual, I wanted to output the probability that that individual was retained on ART treatment. And what this does is it gives a sense of risk, of who is at highest risk and is most in need of outreach and support resources. So this model that I created has actually already been integrated into the Zenesis data platform where it's available for clinics to see it and use it. And as you can see here, I was able to get a very high accuracy in the model. Ultimately, it is 95% of its predictions of whether someone is retained or not are correct. So I think this was a really big accomplishment. But one of the sort of broad, biggest challenges that I faced is that when applying these complex machine learning tools to development contexts, there's a real trade-off that has to be made between transparency and ensuring responsible interpretation, which are both really important to ensuring ethical data usage. So on one hand, I really wanted to enable these healthcare clinics to have as much agency as possible, making decisions about how the model was built, how it was implemented, whether it was implemented at all. But someone without a pretty significant data science background would have a lot of trouble interpreting and understanding this model. So there's a real risk of misinterpretation that can be harmful with things like someone seeing a causal relationship between variables that's not actually supported in the data. So some of the ways I think to mitigate this are, one, to have close communication between the data science, your quote unquote expert, which I guess in this case is me, to have close communication with people on the ground who are familiar with the context and be as transparent as possible. And really good communication for data science is important here. And second, I think at a certain point, there are some top-down decisions that have to be made with something this complicated. So what's important is for the person actually doing the model building, doing the data science work, I think to spend a longer time engaging with the community and really understanding what the situation is on the ground and how a tool will be applied to make sure it's built in the correct way. Thank you very much. Any questions?
All right, let me invite viewers to submit questions through the chat function. Let me ask a first one while that's all coming in, Katie. This is maybe a little tangential to your total focus, but I really was wondering about this as you've been working on it. So if I understand, you get a range of probabilities of different patients, different sex workers. It could be 95% down to 3% or whatever. Is the strategy to try to focus on those kind of at the far end? You kind of get bang for your buck of those at the really low percentages, or to do kind of like the nudge to mix those that are kind of closer to the top and just make sure it's easy. Is it easier for that to move them over the line? How does that look?
Yeah, that's a good question. I think it's more the latter, that there is a focus on making sure that support is given to the most vulnerable or highest risk people within a community. So I did some qualitative interviews with some of the managers of these healthcare clinics, like I talked about, and they really emphasized that they, any single individual who is not retained matters, and that they really want to reach every single person. So I think it's less about just nudging people who may not be at highest risk, but trying to get to the people who need help the most.
All right, lots of questions kind of thinking about how what you may be learning, or the algorithms, how they are coming out, may be applicable to other contexts. Do you see how context specific is this? So in other words, what you find in South Africa, could that be applied to another country in Africa or even Asia? And one question, very interestingly, how might this apply to vaccinations for COVID for all the rest of us, or other kinds of compliance around our current epidemic?
I think the model that I created is pretty context specific, because a lot of it depends on just what metrics these clinics wanted to track already. So what metrics are already in this data platform that they use, so we're not adding things that people need to collect. But I do think that these sort of more advanced data science prediction methods, there's a lot of potential for them to be more utilized in the development space, which is part of the reason I think it's important to think about these trade-offs of how do we use these complicated models in a way that is responsible and communicated.
So another question a little bit about the model itself and kind of risk factors. Were there particular risk factors that I don't know if you have access to the specifics on that came out as being those that are more predictive of non-compliance for whatever reason?
Yeah, something that was interesting is I think the things that increased the likelihood of someone being retained most was actually just having data present. So for example, a lot of people in the data didn't have any race recorded at all, and having any race recorded, regardless of what it was, drastically increased the probability that someone would be retained. So I think this is, again, a good example of being careful about causal interpretation, where really what's being measured is whether there's data there at all. So is some proxy for general engagement with a healthcare clinic and someone's comfort with sharing data. I think just how much data is in there, which values are missing versus which values someone actually has, makes the biggest difference.
Yeah, boy, that makes it, that's fascinating. Let's see, couple more here. So where is this project now? What comes next?
So this project, actually, it's already in Zenesis's platform. So right now it's available to the project partner who's kind of represents this larger network of clinics. So they're sort of playing around with it, making sure they understand it. And then it will be implemented, and these clinics will have this available and will start being able to use it in whatever ways they see fit.
But is there a phase of verification that kind of comparing predictions and
So that was a really big challenge. I think I had a lot of trouble explaining sort of model performance metrics for something kind of complex to the users. So that, I think, would be the biggest thing if I had more time that I'd want to work on, is creating a system for evaluation. Something I talked about with them is having these outreach workers who know the communities best talk about comparing what the model gave them versus who they, if they were looking at a list, would have reached out to in terms of, following up with people who are HIV positive but not on treatment. But I think that's another example of when it's so hard to communicate model performance metrics. It's very hard to set with the stakeholder to set good evaluation and iterations in the future.
Mm-hmm. Just one question, just to be clear in terms of, so if we were to ask you what your findings were, what do you come out of this with?
I mean, I think the most useful thing is coming out of this, providing information to these healthcare clinics that they can access. And the model will continue updating and getting better as it gets more data. I think the main finding is giving these clinics these probabilities of retention, these kind of risk scores. But I would say otherwise, my main finding is that the data that's collected acts as a very effective proxy for what I think are really the most important factors at play, which are, marginalization, a sense of hope for the future, economic constraints, and a lot of people talked about substance abuse as a real constraint as well.
If I may then just use my prerogative as the MC to ask one of my questions as well, to finish up. What do you see this really changing the way healthcare providers are trained, the way they operate? Presumably, I mean, I think you bring out some very important issues, the challenge or the risk of misinterpretation and all sorts of other things. But as this goes in and people get used to this, is this going to change healthcare at that level, or even here as well?
I think at a large scale, so I was very lucky to come in where Zenesis already has this very close partnership with a number of clinics in South Africa. There's already a lot of trust there in terms of seeing data and using data. And it's not being used to make any decisions of denying someone care. It's just about prioritization, which I think mitigates a lot of the potential data ethics issues of using these individuals' data. I think it would be hard to have something similar to this exact project on a national scale or in a government healthcare system, particularly for a group that is marginalized. I do know that a lot of methods like this are already being used for COVID-related prediction. So I definitely think I think that machine learning will be integrated more into a healthcare context and will really change things, but that process is still happening.
All right, well, listen, we could go on and on. There's lots of other questions here. I'll share those with you later, but thank you very much. That was excellent.